All right, hi guys, I'm going to do the key to the next assignment with you. So I'm starting with 42, which is y equals cosine 3/4 x. So our amplitude is of course going to be 1, seeing that 1 is the coefficient here. So this would be a 1 out in front. And then our period for sine and cosine, we'll do a tricky tangent one later, but for sine and cosine, it's always 2 pi over b. So our period is 2 pi over 3/4. And of course, this is non-calculator, so I'm going to multiply both top and bottom by 4 to get that 4 as a denominator. And that gives me 8 pi over 3 is our period. So my period is 8 pi over 3. That's how long it takes to get through one cycle. So I'm just going to sketch. I don't think we have any, no negatives or anything to worry about. So here's what my sketch is going to look like. Cosine starts high. And I know that it's going to take 8 pi over 3 here to get back to its maximum, which means what's half of 8 pi over 3? What's going to be this point on our graph? That's going to be 4 pi over 3, right? And then we can go backwards as well to do 2 cycles. So then that's going to be negative 4 pi over 3 and negative 8 pi over 3. Okay, so I'm going to pause it and graph it and see if you guys can do it. So there's your answer. Pause it. I'm going to check it out. Again, period. I know that's how long it's going to take to get through one cycle, and then I just took half of that. So 4 pi over 3 would be half of 8 pi over 3 to do my scale. Moving on, next one. Okay, I'm going to answer these questions first. So amplitude. Amplitude is A. Looks like it's going to be 2. The period is going to be always 2 pi over b for sine and cosine. Tangent's different, but we're not there yet. So 2 pi over 1/2, which is 4 pi for our period. C asks for a phase shift. There's none. That's the horizontal. That would be left, right, is what a phase shift is. And there isn't any left or right shift, so that would be none. Vertical shift, there is a vertical shift of up 1. That's that +1 in the front there, so that D goes with this. It could be on the end, obviously. They just chose to put this out in front. And then E is the range, and we'll come back to that after we get our sketch going and we figure out what's going on. So I'll come back to the range. Okay, so first of all, how I would start this one is it's cosine. So I would originally think of my parent graph is cosine. It starts high, goes low, and goes back up to its maximum. We also have a reflection here, so I would immediately think, okay, this is going to do the opposite of that. It's going to start at the minimum and back down. There's negative cosine x. And if we want to think about the fact that the amplitude's 2 already, also, we could just know that this is going up to +2 and down to -2. So here's this. We'll get the period in there in a second, but the only thing that I know now is that this has to be shifted up 1 unit. So this whole thing has to go up 1. So that's going to now make my sketch be starting at -1 and going all the way up to 3. So this is from -1 all the way to 3. And that midline will be right here, +1, amplitude of 2. So the range, now I can answer that question, is going to be between -1 and 3. So now we have our sketch. Now we just have to worry about our period. Our period was 4 pi, which means I know this is going to be 4 pi here. So then let's think this maximum is going to occur at 2 pi, correct? So now we have a good idea of a scale to use. So I'm going to pause it and I'm going to do my 2 cycles, one forward, one backwards. You guys do the same thing and let's see. Here's my finished product, guys. That was a tough one. But notice that midline. It's important to kind of keep track of that midline so that you know where it's at. That midline here is at y equals 1. Okay. Okay. For number 69, that's the one where you're looking at that graph. There's an average temperature graph. So the maximum and minimum average temperature, that's really easy. That's just 40 degrees and negative 40 degrees. The amplitude and period, it's easy to find the amplitude and period. What they mean is a little tricky. So the amplitude's 40. What does that tell me? That tells me that really there's like an 80-degree split between the min and max average temps. So that's what that amplitude tells you. The period, it appears to be 12 on the graph. So temperatures are going to cycle back through average temperatures. Average temperatures will cycle back through each year or every 12 months. So that's what the period is going to mean. Explain what the x-intercepts represent. The x-intercepts look like they are 4 and 10. And so this would mean the 4th and 10th month. That's the average temperature for those months is 0 degrees Fahrenheit, is what that is indicating. Okay, 24 on the next set of pages here is just a multiple choice question. For the multiple choice question, says which one of the following is true about the graph of y equals 4 sine 2x. So obviously that's the amplitude. And this is going to give me the period. So period is still always 2 pi over b. 2 pi over 2, which means the period of that would be pi. So which one says that? It's looking like it is choice B. Yay. All right, 25, we have another graph. You guys should be able to do this one completely on your own. So I'm just going to pause it and do the key. Okay, that one should have been easy peasy. Here's sine x over here, starts at 0, 0. We know the period's 2 pi, not even any shift in frequency or anything, and then amplitude. Easy one. Okay, after the last one being easy, this one is definitely not. So first of all, let's start with, we've talked about how we have to have the signs of sine and cosine kind of memorized. Same thing as a tangent. You guys haven't really seen this one since the video from last time on Academy, the intro to tangent. So go back and watch that if you have to, or you can just watch this a bunch of times. But tangent, it goes to the origin, and it is really funky because what happens is it's also cyclic, but we have some vertical asymptotes going on. So you need to have the general gist of this memorized is that this, where it's undefined here, is pi over 2, and then this is negative pi over 2. So 90 and negative 90 are where it's undefined, but it kind of increases, has this pattern in the middle here, almost like a cubic pattern it looks like, but it goes through 0, 0. So notice that the period of regular old tangent of x is pi, right? Because there's half a pi here and half a pi here, so it takes pi to get through a whole cycle. That's different than sine and cosine, right? Because sine and cosine takes 2 pi to get through a period, and this only takes pi. So therefore, to find the period of a tangent function, instead of doing 2 pi over b, you do pi over b. So it's normal period dividing by the frequency. So here, the period of this one, this specific one that we're talking about in this problem, is going to be pi over 3, is how long it's going to take to go through a cycle. Okay, and we are going to graph two of these at least, so I'll talk about how we're going to do that. So first of all, I'm going to make this pi over 3 and negative pi over 3. Oh, no, I'm not. Just kidding, redo. We know the whole period has to be pi over 3, so therefore I want a half on this side and a half on this side. So if I want it to take pi over 3 to do this full piece here, then I know that these asymptotes are going to occur at pi over 6 and negative pi over 6, right? Because pi over 6 and pi over 6 is going to total give me that pi over 3 I'm looking for. Basically cut that in half. So this is going to be pi over 6, and this is going to be negative pi over 6, or where those asymptotes are going to be. And then we can make our smooth little curve in the middle. Okay, so there's one cycle. So now we have to do another one. So we might as well just keep going out by pi over 6. So if I keep going out by pi over 6, this would then be 2 pi over 6, which we can reduce, but I'll leave it like that in a second. This guy would be 3 pi over 6. This guy would be 4 pi over 6. So that's enough. We don't really need more than that to do another cycle. So here would be where the next asymptote would be. And here is where the next, that one's even extra. We don't really even need that one. We're only going to do one more cycle. I just did it like this so that you guys could see non-calculator what these were, but of course if this is a real graph, you're not going to see it like this, you're going to see it in reduced form. So that x value there is actually pi over 3, right? If I reduce that, 2 6 1/3. Same thing here, you're not going to see it like that. 3 pi over 6, that's actually pi over 2 right there. So just those in reduced form are what you would actually see on a graph. But there is my y equals tan 3x, tough one. We should something, but that one's, yeah, new and tougher for sure. Big thing, period, is pi over b for tangent instead of 2 pi over b. Okay, let's write down everything that's going on. First, we have a amplitude is 1/2. We have a period of 2 pi over 3. And we have a reflection in the x-axis. So this is going to look like, let's sketch. Here's my regular cosine. That's cosine, my parent function. We are flipping her over the x-axis. So it's going to look like this. And we know it's only going to go up to a half, down to a half, negative a half. And our period being 2 pi over 3. Okay, so if this is 2 pi over 3, then that means it's going to hit its maximum halfway is 1 pi over 3, or pi over 3. Same thing on the other side. So now we have my sketch. We should be able to, you should be able to get it yourself. So I'm going to pause it and do my. All right, there's my y equals negative 1/2 cosine 3x. Okay. Next, y equals 2 sine 5x. Okay, obviously amplitude is 2, period 2 pi over 5. So you can do this one on your own. I'm just going to do the key. Check out the answer. Hopefully you guys are getting better at dealing with the period here. So I just think it's easiest to kind of do it on the sketch and then take half of it to see where that point is. Easiest way. So next one, 29. Ooh, 29 is a lot going on. Okay. Off to the side, let's see, we have amplitude is 2. We have the period is 2 pi over 1/4. So that's going to be 8 pi. And we have a vertical shift of up 1. Nothing else going on there, no reflections or no. Okay, so there's 29. So my sketch, let's see, my normal sketch would look like this. And we'd be going, it is sine, yeah, we're going 2, -2 would be normal. But then we got to move this guy up 1. So now if I move it up 1, that's going to only go down to -1. And we're now going to be going up to 3. My midline is going to be here at 1, just so you can see what's going on. So now we're going to go to 3, down to -1. Same thing here. Okay. And we are taking 2 pi, or no, not 2 pi, geez, we're taking 8 pi to cycle through. So then that's going to be 4 pi. Okay, so now I'm going to start graphing, see if you guys can do it. I'm going to pause it and do the key. Okay, here's the answers. How'd you guys do? Notice again midline here. That helps. Okay. These ones were just, you have to identify one that fits the description. So 45, the big indicator here is the period's pi. So this is going to be tangent. The other ones are 2 pi. 46 period's 2 pi and passes through the origin. That's going to be our good old sine function. So that's sine. And for 47, the period is 2 pi again, passes through the point pi over 2, 0. So that is going to be, if we, remember this is 2 pi, this is pi, so this is pi over 2 for cosine. So this is cosine. There's your answer key, you guys. Hope that helped. Bye. Bye.